Okay. Yeah. Hi, everybody, and welcome to ICS Arabia, where I interview professionals, ICS cybersecurity professionals from all over the world. I normally, interview guests in Arabic, but sometimes I do it in English. Depends who's the guest. Um, as you know, last time I talked about zero trust in Arabic with my friend Shakir. We talked about the concept, the methodology, the standards, how to apply it. But this time, I'm gonna talk about zero trust again because I found an interesting project, open source project. I'm an advocate for open source, and what attracted my attention that I saw a zero trust project in GitHub called OpenZT, and it's backed up by a company, Netfoundry. As you know, the cloud is coming really strong to the ICS world, and there is no escape from it. So the challenges are expanding, and there is something to be discussed about this challenge in this episode with my guest, Philip Griffiths. Hi, Philip.
Hey, pleasure to be here. And
Nice to see
sorry,
you.
I can't speak Arabic.
Okay, no problem. Um, so, could you tell us, please, about before we go into OpenZT, let's discuss why there are challenges in or why the networking is broken.
Yeah,
Uh,
I'm very opinionated in this area. Um,
yeah.
the, in my opinion, if you look at networking, to borrow your words, it is broken. And the reason I think it's
Mm,
broken is because, and demonstrably broken, because we continue to have cyber attacks every single day, whether it's against ICS and OT infrastructure or outside of general internet-based infrastructure. And it's almost become the de facto normal for things to be attacked. To the extent it's almost not news anymore when
mm,
major attacks take place. And
mm,
we have conversations at the moment where people are talking, if a war happened between superpowers, we would be taking out each other's critical infrastructure left, right, and center
mm,
because we're dug so deep into power systems and manufacturing systems and various other connected things. And so this comes in my opinion, the demonstration that is broken, which is we have built wonderful networks to connect things and to build digital systems.
mm,
But fundamentally, there is no such thing as a secure network. There
mm,
are only private networks. And so in ICS and OT, we built things like the Purdue model and cells. And we said, oh, let's make sure that we do outbound only connections. And um,
mm,
we therefore stop this scary outside world from coming to our critical control systems.
mm,
But yet ICS systems get hacked because we have to connect this drill system or this manufacturing system, this PLC. I mean, Christ, people are putting PLCs on the internet,
mm.
and we do that for convenience and for getting
Yeah.
data. But it comes back to that there is no secure network; there are only private networks, and
Mm,
so our thought process was rather than trying to incrementally create a better VPN or a better
mm,
firewall or a better data diode, how do we square this circle? There is no such thing as a secure network. There are only private networks. We used to use air gaps and physical infrastructure and physical wires like MPLS, um, but this does not work in a world where software is king. Software eats world, hyper connected. And at the end of the day, we don't care about securing our network. We care about securing the systems, the data, the applications, the controllers which are actually uh, operating in the physical world.
mm,
And so our thought process was considering all of that,
mm,
we need to make private networks which operate as software only, which can actually be embedded directly into the applications, directly into the systems, so that we treat the underlying network as compromised and hostile.
mm,
Uh, Zero trust as a philosophy says treat the networks as compromised and hostile.
mm,
But we think that was not taken to its logical conclusion, which is every network should be treated as compromised and hostile. Not just the internet,
mm,
but the LAN, my layers of the Purdue model, whether it's 3, 2, etc. They should be treated as compromised and hostile.
mm,
Even the host OS network, the machine that I'm running on, that whether it's Linux or whatever operating system, I should not be trusting that network, because if malware gets onto that machine, it can move across that network. And so that was our process. How do we treat all underlying networks as compromised and hostile? Therefore, we need a private network which operates as software, which can go directly into the application, directly into the machine, and treat all networks as compromised and hostile. And we looked around and we went, well, that technology doesn't exist. So we're going to have to
mm.
create it ourselves. And therefore, we created OpenZT. We created the ability to put private, isolated overlay networks into absolutely anything. And through the journey, we've actually found, what? The area that needs this most is ICS, it is OT,
Mm.
because they are increasingly becoming connected and they're
Yeah.
increasingly being attacked. And we need to be able to have our cake on eat it. We need to be able to connect these systems. We need to be able to create them and make them smarter, but we need to ensure they are secure by default. And therefore, we're able to transform our processes and our operations and have them secure.
Interesting. So, what does ZT mean, if I may ask?
Well, there's two ways to answer it. Number one is ziti. Ziti is a delicious Italian pasta. It's almost the opposite of spaghetti. So it's like long, thin, but it's hollow in the middle.
Hmm.
But actually came around where we were sitting in a room and we were whiteboarding where we're creating this project. What the hell do we call it? And someone was going zero trust ZT. ZT. ZT is an Italian pasta. Let's call it ZT. And
Yeah.
then we went, well, it's going to be open source. Let's call it OpenZT. Because if you put just ZT into Google, then it's like make a lasagna, make a pasta dish. And we're like, well, we have to put
Yeah.
OpenZT
Yeah.
so people find it. And then we thought, as it's an open source project, that gives us our mascot, because every open source project needs a mascot. If it's it's Golang, it's a little gopher. For Linux, it's the penguin. For us, it's
All right.
Ziggy, a little piece of pasta.
Nice. And did the company develop the project, or was it there before Netfoundry?
We developed it.
Oh, the
So
company.
it was
Okay.
very much we had those first principles, we had those ideas, and we looked around and we thought
Hmm.
that technology doesn't exist. There are primitives, there are open source libraries and capabilities which allow
Hmm.
us to do this function and that function and that function, but we need to write a load of code ourselves that pulls together those other open source capabilities, but then delivers that whole capability to be able to apply zero trust network into any case we want to throw at it.
Interesting. Um, so why the company adopted the open source, let me say, business model, or
Yeah,
yeah.
two reasons. Reason A
Hmm.
is our goal for ZT is to turn it into the equivalent for Linux as Linux. But
Linux.
instead of being the open source operating system, instead the open source zero trust overlay network, where by default everyone will just build it into their system. Because if you do that, your system cannot be attacked from the network. It cannot be attacked by IP
Hmm.
based attacks. So all of a sudden, looking at the MITRE framework, a whole amount of attacks just can't take place. And this therefore enables systems, applications, infrastructure to be built as secure by default. Now, that's a grand idea. The other, and so the only way to do that, the only way to get massive adoption, to effectively create a standard, is to open source it. The other is that if you want to convince developers, whether it's an application developer or an OT developer, or people that are building things to put stuff into their applications and systems,
Mm,
they're going to go, well, is it proprietary or open source? Because if it's open source, I'll happily adopt it. If it's proprietary, I'm not sure anymore,
mm,
because now I'm tied into your company, your business model, etc.
mm,
And we work with. In fact, my call just before this one was with a let's call them a robotics company, and they're looking at building ZT into their system so that wherever the robots are around the world, they're secure. They don't have to use VPNs. They don't have to worry about firewalls, inbound ports, etc. And so they started off on the open source. They're going, great, we can just build this into our system. And if we want support from you, if we want your managed version, we'll use that. If not, if we decide in the future we don't want to pay you or to work with you, then we can go on our own.
mm.
Again, if you take the analogy of Linux, you can use Linux yourself, or you can go to Red Hat, or you can go to Ubuntu, or you can go to SUSE, or you can go to these many different companies that provide their flavor of Linux. And so for us, it's very much we open sourced it because it drives the adoption, it drives people
Yeah.
being able to build it into their projects and their applications, and then you create this ecosystem, and hopefully our company Netfoundry will be the company that people will turn to for the supported managed version, but there will be other companies that provide it as well.
Mm. Interesting. Aren't you afraid of, you know, like malicious users look at your code and do some malicious stuff or supply sh chain issues, etc., etc.
So there are multifaceted answers to that.
Mm.
The most immediate one is security through obscurity, in my
Mhm.
opinion, is incorrect. Sure, you may make it a little bit harder for someone to find you and to exploit you, but ultimately they will. When we look around, whether it's SolarWinds or the Avanti
Mm.
attacks or the Move IT attacks,
Mm.
these are all commercial closed source products where the malicious actors have found an exploit, a 0-day, a CVE, and they've been able to um, test it, to weaponize it, to demonstrate it on a small scale of customers before they then take over a large amount of instances. By developing in the open, we have people coming to us and going, actually, you've potentially got an exploit here, which should be fixed. Although, actually saying that, we have had people look at the code. ZT is used in some, let's call it military 3-letter type agency use cases, and they've looked and gone, yeah, this is damn good code.
Mhm.
But also, so not only do I think it's more secure to be in the open rather than through obscurity, but also we've built ZT to be deny by default. So even if there was an exploit, that doesn't mean you can necessarily do anything with the system, because you cannot, for example,
Mm.
one of the aspects of ZT is a smart routing mesh network.
Mm.
And that mesh can sit on the public internet, or it can be in a private network, it can be anywhere you want. But let's say as a malicious actor, I'm able to get to one of those nodes, and I can get inside that the memory of which that application is running and try to play around with it. You can't laterally move, because connectivity is between the edge and the edge, and the connectivity which is established between the different hops in the overlay is based upon the policy within the control plane. And so taking over a node or attacking a node, that doesn't give you anything. This, in my opinion, is really the crux of doing zero trust correctly. It is that you are denied by default. Even if you somehow manage to exploit part of the system, you're not able to laterally move, you're not able to orchestrate an attack. So there's a whole plethora of things, whether it's denied by default, whether another is ZT is making outbound connections on both sides. So you
Mm.
cannot just find the endpoints on the internet and attack them with a network-based attack. But even better, if you're embedded in the application, you cannot be subject to external network attacks. You cannot be subject to IP-based attacks. So the Yeah, our philosophy is do it in the open, so you make it more secure by default, but
Yeah.
also build a system which is secure by default, so that even if, and yeah, all software has exploits. I'm sure one day there will be an exploit against CT,
Mm.
but when it exists, it won't allow attacker to take over the system, to laterally move, to be able to exploit the system in the way that, again, Move IT, SolarWinds,
Mm.
whatever these attacks, the malicious actors have taken an exploit and then they've been able to laterally move. That's the issue.
Okay. So how do we apply it in ICS networks or OT networks?
There are many different use cases. Five immediately come to my mind because ZT is an IP based overlay network. I mean, you could tunnel something over it, so you could maybe do like a layer 2 VXLAN tunnel over tunnel.
Mm.
But let's just start from the assumption that we're tunneling IP.
Mm.
Um, Whether you're doing client server, server server, machine server, client machine, doesn't matter.
Mm.
There's no concept of client or server actually in ZT. There are endpoints, and you can host a service or access a service.
Mhm.
So three areas with five use cases.
Mhm.
If I am a industrial product maker, say I'm building PLCs, or I'm building edge gateways, or I'm doing protocol conversion or something like that,
Okay.
I have a hardware software stack in my ICS network, and I need to connect it to the cloud to do software over the updates,
Mm.
SSH connections, push, logs, monitoring, etc., etc. So let's call that control plane connectivity between the infrastructure, which is maybe in the DMZ or maybe layer three,
Mm.
to the cloud. Okay, that's one use case. It's effectively machine server.
Mm.
The next use case is um, uh, for connectivity in the network. So maybe I'm connecting a gateway in my DMZ to a cell in layer three. Because we're starting to see PLCs and other edge infrastructure that actually running stripped down versions of Linux, and they're using Ethernet, IP, etc. So you can effectively have connectivity between in your LAN environment, in your OT network, between the perimeter and
Mm.
the lower cells, but to make sure they are outbound connections, so we're compliant to Purdue. So
Mm.
effectively, we're now talking about machine to machine
Mm.
within that OT network. There is then, and that's both of those use cases for the hardware software providers
Mm.
in the industrial scenario. There is then the third use case of remote access, so client to machine, whether it's someone locally in that factory or manufacturing site, or someone external to that site. And particularly, we speak to a lot of organizations and go, I've got 12 different vendors in my OT network, in my ICS
Mhm.
network. I need to make sure they only get access to their machine when I say they should for a certain period of time, and then I can cut it off and they get access to nothing else in my network.
Mm.
And we give that ability to effectively create identity driven ephemeral access to services exactly when they require it. A very good demonstration of this, actually, how we use it ourselves.
Mm.
We got a nice blog on the ZT website around, I think it's titled something like ephemeral business access. It was written by our CISO. um, our engineers do not just have access to customer resources for our cloud product.
Mm.
The only way in which they get access to customer resources is if the customer opens a ticket, the assigned engineer gets given access to the specific resources only for the duration of that ticket being opened. And when the ticket's closed, their access is removed, so that there's no connectivity otherwise, because they're denied by default model. And the only connectivity is explicitly to the resources when it's allowed for the correct person.
Mhm.
So having that real control over giving remote access, again, whether it's in
Mhm.
the local OT network or the external providers on
Yeah.
an endpoint basis, so you can't laterally move in the OT network. The fourth use case is similar to the first one, which is for connectivity between the OT environment and the cloud, but instead of for specific vendors, now this is for the OT customer
Mm.
or the OT company, where again, another recent use case, they said today, if we want to move data from our OT network to our OT cloud, we actually have to go through the IT cloud. And we've got, MPLS or private connections, VPNs, etc., between our factories or our, oil wells or whatever the ICS or OT environment is. It's going to the IT infrastructure, which is kind of you see in the Purdue model of going up to layer 4 and 5. And then it goes to our OT cloud. So maybe we've got data mixing together. It's difficult to give access to third parties. To which we go, well, that's a bit insane. Why don't you give your OT network a an overlay network which is fully private, Purdue compliant, and you can go direct to the OT cloud. You can ensure that that IT OT data isn't mingling together, and you're not having to jump through different hops or incur egress fees or have complexity. Instead, we can say this machine sends data to this database or this AI service for whatever use case we have.
Mhm.
And then finally, the fifth use case, again within the OT environment, is how can I connect things within the LAN environment? How can I connect the lower down cells to services, shared services that may be running in the DMZ, and to do it in a way that treats the underlay network as compromised and hostile. We're doing actually a really interesting project. I can't say any names, but it's effectively how can we have a monitoring system in our ICS network so that if we think someone has compromised it, not only do we know that's happening, but we use that input to re-architect the overlay network. So
Mhm.
we can say critical services are maintained, but other ones are turned off. Or we think this specific host or machine has been compromised, therefore we redirect its network to a honeypot. Or whatever policies or outcomes you may think to choose, instead of having to change IP addresses and DNS and other things which are very fragile and complicated, instead we can just use an ephemeral overlay network to reconfigure how traffic is connected within the OT environment and then to the external world, to really be able to react in real time based upon the threats that we see within the ICS environment.
I listened to one of your developers. I think his name is Chris, maybe. I'm not sure.
Clint?
Chris, or what's the name of your developers? They show up on your YouTube
I would
channel.
say Clint. Clint.
Clint, yeah, yeah. I listened to him, and he said even ransomware, you can protect yourself from ransomware by using. How could this be? I mean,
Yeah. So in fact, let's take another hack. The I'm blanking on the name. The password manager, which was recently compromised, their compromise happened because malicious actors figured out a staff member that worked for the company
hmm,
had a home lab environment, and they connected from that home lab environment on their laptop to the cloud infrastructure where they do the
hmm,
password management. So they were able to laterally move across, and that's because that person has a VPN or SSH or some very coarse network access from their device to the cloud infrastructure. And so the malicious actor went, well, I'll put ransomware or malware onto that device. I'll laterally move across that network, and then I get into the cloud infrastructure, and then I'm able to exfiltrate data, etc., etc. Now let's change the model.
hmm,
Let's say the engineer, instead of having a VPN, which effectively says, I trust this host and I'm connecting to another trusted host,
hmm,
instead, I'm going to put a zero trust network inside the administrative application.
yeah,
So on their laptop, they've got an application, thick
hmm,
client, and or maybe they're doing browser access or something like that. And instead of having a network on the host level, we've got an overlay network in the application. Malware can be on the host, but it can't get into the network because the network's inside the application. And
Mhm.
so, to an extent, it doesn't matter if there's malware on the host because we're not trusting the host OS network. The
Mhm.
network is in memory in the application. And so it's not unhackable, but two important things. The malware would have to somehow break into the application, which is no, that's not easy. And then even if it gets inside the application, it can only do the things that the application's allowed. It's not an IP-based
Mhm.
network, so it can't just move across and then laterally move in the environment. It
Mhm.
can only, oh, I can do a command, or if it's a chat app, it can send messages. Well, a message isn't going to be able to laterally move and compromise
I
my
get.
environment. And so you move the attack surface from I take over the host, I can laterally move to absolutely minuscule. And for us, this is the key aspect. There's no silver bullet. You can't. Well, the only way you make a system completely secure is you disconnect it and you throw it in the ocean and it sinks to the bottom. But no one's going to get inside that. The question becomes, how can I reduce my attack surface by orders of magnitude?
Mhm.
If your application embedded, your attack surface is minuscule. But you can't always be application embedded. And so this is why with ZT, we've created non-application embedded options where you deploy onto the host or you deploy into the network because it's better. We have some organizations who've gone, in fact, we have a lot of deployments of ZT in Germany because Germany has recently implemented a lot of legislation to ensure higher security for critical infrastructure. So even if you're an SME, there's now legislation that says you have to really treat security seriously.
Mhm.
So there's been a lot of deployments of ZT into Germany to align to these requirements. And one of the organizations we spoke to said, my customers, they don't even want to use tunnelers. So they don't want to have to deploy ZT onto each individual host. They just want to
Mhm.
have an edge router in the DMZ, which then builds connections to all the resources in that environment. And they were like, we know it's not very zero trust, but at least it's better because we can, block all inbound connections, so we stop external network attacks. But they went, can we do something a bit better? So one of our developers developed a capability called, I think, source IP allow. So effectively, you can define the IP addresses which can send traffic to the edge router. And if you're from a different IP address, the packets just get ignored. So kind of similar to your traditional NAC type capability.
Mhm.
And this is the key. Depending upon your environment, what are the deployment architectures that you can do? Because each deployment architecture reduces your risk by another order of magnitude. And if you can just deploy at a network level, great. ZT and Zero Trust is still going to be more secure than using bastions and VPNs and MPLS, etc., etc. If you can go to the host, even better. Now I don't trust the local area network. If you can go to the application, amazing. Your attack surface is minuscule based upon your requirements, based upon the legislation you're subject to, based upon how your infrastructure is deployed. You can make those decisions. Security is always a question of um, balancing risk, usability, and cost.
Mhm.
We built ZT to ensure that we can meet that regardless of the challenges that are thrown at it.
Okay. Say, I do search for ICS devices most of the time. That's my research, and I have a tool called ICS Rank to find. It's my project to find ICS devices. What
Ah,
I find mostly web interfaces to manage
yeah,
the PLCs.
yeah,
Could you suggest how could ZT contribute? I know they shouldn't be online, the web interfaces, but how could ZT minimize the risk of these exposed
yeah.
PLCs or web interfaces? How?
Yeah, 100%. The simple answer is whether it's the producer of the PLC or the company using the PLC,
Mhm.
they can have ZT deployed onto or next to that PLC, so that effectively we're building outbound connections into an overlay network that's only listening for authenticated connections. So
Mhm.
now that PLC is not on the internet. There is no way to port scan it, to try, to find it via your tool or Shodan, and there's no way to do a
Yeah.
network exploit against it. But that endpoint can be accessed by another ZT endpoint, which you have explicitly said, I'm going to allow access. So for example, let's say I have a factory and I put ZT in front of my PLC, and then I say, I'm going to give access to Sulaiman.
Mm.
And now I either say, load this little piece of software onto your Android phone or
Mm.
your Mac or your Windows, and I'm going to give you access to this PLC. So I push policy to your endpoint. I push the policy to the piece of software running in the ICS environment, and
Mm.
now ZT ties that all together so that you have access. Even though you're in completely private networks, you can be given access to just that PLC. There may be other things running in that ICS network. I don't want to give you access to those. I'm just giving you access to that PLC.
Mm.
And maybe you say, you know what, Philip, I cannot load a piece of software onto my device because it's locked down, or you know, it's the laptop from the IT department and they don't allow me to load software or something like that. And I go, no problem. Because we have this design goal with ZT to have the highest level of security with the highest level of usability, because ultimately if users have friction, they want to throw away the security. We have developed various different application embedded approaches, and one of those is to be able to access via your browser.
Mm.
Now, there are several vendors who say I can do zero trust browser access. In a nutshell, there's two or three. There's three ways they do that. One is you have to load a browser plugin into your browser. That requires you to do work. Number two is they do a DNS redirect to their infrastructure. So it's just a HTTPS connection from your device to their infrastructure, and then they re-encrypt and send it over the overlay. That means someone needs to mess around with your DNS, probably central IT. The third option is that you're just doing a HTTPS connection to a public URL, and then from there, you're being intercepted and taken to the PLC. We have a technique which brings the zero trust connection all the way into your browser tab without you doing anything. And we call it browser, but instead of with an S, we put a Z inside it, because everything we put ZT inside, we put Zs in the name because we're cute and clever. This gives you a public application experience. You just enter a URL into your browser, you authenticate to Google, whatever your IDP is, and boom, you now get access to the PLC. So it seems like the PLC is just on the internet, but it's not. The way we do that is when your IDP, so like Google is giving you your X509 certificate, so your cryptographic identity to make sure that you're authenticated and authorized, we're also loading an agent into your browser tab without you realizing. So we can give that really high security. The PLC is not addressable on the public internet, but for you, it seems like the PLC is just on the public internet. And again, this is really our design goal. How can we have super strong security, but how can we make it super damn easy for end users so it doesn't seem like that there's this super high security between them and whatever they're trying to access? Yeah.
Okay. So what you're saying that the company shouldn't expose their web interfaces, PLCs, but they should adapt the ZT approach. That it
Yes.
acts like it's in the public, but it's not in the public. That's what I understood. Yeah.
Exactly. You just never put your PLC on the internet. You know, the Purdy was built for a reason to protect our critical infrastructure. But you know, we need to potentially have engineers remotely access, or we want to grab data from the PLC. We want to be able to digitize our business and make good decisions. That's all very legitimate reasons. So let's use technology which enables us to connect those PLCs and the other stuff that sits in our ICS environment and easily move that data to the cloud, or enable people to remotely access, but to do it in a way which is frictionless for the end users. ZT provides that, and it's free and open source. So there's literally no excuse not to use it, other than you might say, well, I don't want to have to manage it. I don't want to have to host it. I don't want the free and open source version because I want SLAs. I want people I can shout at if something's going wrong.
Okay.
Great. That's why companies like Netfoundry exist, to provide effectively a commercial hosted managed version of it. So you can go in either path. and either path we're happy with, because our goal, as said, is to turn ZT into the equivalent of Linux. Linux runs the world, and ZT will in the future.
So you're the Linux of OT then.
Yeah, uh, of secure OT networking. Yes.
Yeah, yeah. How can we embed, or is it possible to embed ZT in a PLC, say while they're developing the software for PLC, controlling PLCs? Could it be embedded?
It could, yeah. I mean, there's many options. We some of our customers, and a PLC nowadays is probably running some stripped down Linux like
Mm,
OpenWRT
yeah.
or EWRT or something like that, or maybe some industrial Linux. Great, we've got a Linux endpoint which can deploy onto any of those. If you actually want to go application embedded, then we have a suite of software development kits.
Mm,
So, for example, the CSDK
mm,
compiles down into like kilobits of space or kilobytes of space, so you can run in really constrained systems. In fact, we have a project that we're working on at the moment called Foundry.
mm,
Foundry is part of the Linux Foundation, and their job in life is to provide a edge runtime, and they particularly do capabilities around protocol conversion.
mm,
So I want to take a industrial protocol and be able to turn it into something that an IP system can utilize and consume. About a year and a half ago, they were looking at moving to their 3.0 architecture, which meant doing some improvements such as removing components which they had taken from the cloud native area, and they wanted to make them more edge native, which means effectively how do we go from hundreds of megabytes of memory and storage and large CPU requirements, where in the cloud these things run
mm,
limitless, to constrained, to much smaller binaries.
mm,
And while doing that, there were some other capabilities they wanted to develop. So we outreached them and said, why don't you consider actually building ZT into EdgeX Foundry? Because then you'll solve those problems. You'll have much smaller binaries, but actually you can actually build, rather than being a standalone component, you can actually build it directly into your binaries so that you don't require extra agents,
yeah,
daemons, etc. But you also make it so that the communication between those components, natively, I think they were using HTTP, you encapsulate that so that you've got secured connection between all those components, so you don't trust the edge network. And when you want to make a northbound connection from the edge to the cloud, you're doing that over a zero trust connection. So you're not trusting that. You don't have to worry about bastions, VPNs, public DNS, etc. And they were like, that's an interesting idea. Fast forward to today, one of Clint, in fact, is doing the work to build ZT directly into all of their binaries,
mm,
and it's going to be released as part of the Odessa 3.2, which comes out in April, I believe it is, so that it is native to their solution, and they're using the Go SDK because their solution is written in Go.
mm,
So going back to your question,
mm,
yes, you don't have to build ZT directly into the system or into the application, but
mm.
if you can, it's very easily doable. We're working with a few industrial product makers who are going exactly down this path, because
All right.
if you sell, for example, if you sell into the US, the DOE, being
Mm,
driven by the Biden government, is very
mm,
much going, we need zero trust everywhere. We know malicious actors, we know nation states are
mm,
breaking into our critical infrastructure, and at any moment they could turn parts of it off because they've burrowed so deep. And so there are huge investments going into research institutes and the product companies that are building hardware software stacks for distributed energy systems and manufacturing, and various different things, where they're a key part is saying you need to build zero trust into your systems.
mm,
You need to ensure end-to-end encryption. You need to ensure deny by default, least privilege,
mm,
micro segmentation, etc., etc. And so we're working with these companies that are going, Well, why would I build all that myself when I can just build ZT directly into my hardware software stack?
Mm.
And it just works. I have that capability. Um, Again, I can't share any of those names today, but
Yeah.
hopefully very soon some of that will be public. And again, the goal is the companies that produce this equipment, the PLC companies, the MES companies, etc.
Mm.
This will just be by default. And then if you're an ICS company, all of your stuff that gets shipped to you, it will have zero trust built into it, so that you're secure by default. And that doesn't mean you have no responsibility. Sure, you still need good cyber hygiene, but
Mm.
the barrier of attack went from, hey, if you get on my network, you can potentially compromise things, to just secure by default, way higher.
Interesting concept. I hope it shows. I hope it shows in the future. Uh, so, so what I understood from you that companies that use RDP, SSH, all these proxies, tunnels, they could be replaced by ZT. Is this
Yes, with a caveat.
all right?
ZT is a at its most simple level, it is a incredibly private, obfuscated, and isolated bit pipe to take packets from point A to point B in
Hmm.
a smart, low latency way. It is operating, if you look at the OSI stack, 3 and 4. ZT is not operating at a layer 7. So ZT is not doing SSH, RDP, or whatever protocol you're looking to do. It
Yeah.
provides the transport to do those
Hmm.
capabilities on top of it. So if a company needs to do SSH, then, for example, then they can be doing it on top of ZT, but they'll have an SSH client and server on both sides to be able to make that.
Hmm.
In fact, one of the demonstrations we did is we took a Golang based SSH client server and we built
Okay.
ZT into it, and we call it, as you would guess, ZSSH, and that enables you to have
Yeah.
zero trust built into that SSH connection. We have also developed a project called ZRock.
Hmm.
ZRock started out as a let's build a better ngrok. I can have resources in a private network and I can share it on the public internet via a
Hmm.
URL. And I can put some auth in front of it so that it's protected. And it operates at layer 7. And so you can start potentially doing those types of capabilities, like an RDP or an SSH or other things via ZRock. And ZRock is effectively an application built on top of
Zero.
OpenZT. And very much it was the reason we started doing it is it's a demonstration of we were able, we've got one developer working on it. He's been working on it for about a year and a half, and he's written a load of really, really nice code. And that's been a lot of effort. But what he's built, if you were to build it from scratch, 4, 5, 6 years, something like that, and the reason he's been able to do it 4 times faster is because he inherited a lot of capabilities from OpenZT. So he didn't have to worry about how do I do keys, how do I do tunneling, how do I do DNS, how do
I
I
get.
do segmentation. He got that all from ZT. How do I have an Android client? How do I have an SDK? He got that all from ZT. He puts a wrap around it. Now he's got it for ZRock. So yes, you can do all of those capabilities on top of ZT, and we're building the tools to make it even easier and quicker for organizations.
So the word is Zetify everything.
Yeah, yeah, you're learning. You're part of the community now.
Yeah, I've done my homework. I mean, I've watched a couple of videos about you.
Actually, I've just thought that so today I am actually wearing one of our ZT t-shirts. So this is one where he's frozen. It says
Who's this guy?
so this is Ziggy. So he's the piece of
Ziggy.
pasta. Ziggy,
Oh.
yeah, but he's frozen because it's cold, and he says, don't leave your app in the cold outside. Now that you're becoming part of the community, we'll have to send you some of the swag that has ZT on it, so you can.
Okay, thank you.
My favorite one is
Yeah.
I should have worn that one actually. So we have a ninja one where he's like as a little ninja. It says like make your apps invisible or something like that.
Well, my uh, one of my family, she is now in Bournemouth. I'll give you her address.
Ah, yeah, happy
Please
to. I always laugh as well because
Yeah.
my kids now absolutely love Ziggy. So whenever
Yeah.
they'll come into my office and they're like, "Show me Ziggy," and
Yeah.
they'll look at them. And they've got all their favorites. And a few
Mhm.
weeks ago, I was walking around the house and I found one of their books and it just had like three Ziggy stickers stuck all over it. I was like, "Oh man, I have to make sure they don't get the stickers."
Yeah. Ziggy, Bob Marley's son, I think his name is Ziggy.
Ah, really? Yeah,
Yeah.
cool.
So it's all Z, the letter Z.
Zed's everywhere. That's
Z's
exactly what we do.
everywhere. It's like, I don't know. When you told me the meaning of ziti, it's like a cooking recipe. And now you
Yes.
you you're adding the recipe everywhere.
The a lot of our blogs make analogies to cooking.
Yeah. Okay. Thanks, Philip, for this uh, presentation. Nice interview.
It's a pleasure.
And it's nice to have you. And I hope the best for everybody.
Thank you so much. Maybe we
Yeah.
can have another conversation in X amount of months and years when all ICS companies are just building ZT directly into their products.
Yeah, that would be nice. I mean, I look forward to it. Anything you want to say, Philip, before we go?
Just if any of this is interesting, reach out to us. We love to understand use cases and capabilities and how we can help to solve them. In fact, I've got a conversation with
Mm.
a company that provides solutions into the ICS space on Monday. And they've sent a whole bunch of, well, we'd love to be able to do this. And we're looking like, ooh, I mean, ZT doesn't do some of that today, but could we do it? And that's we develop the product and the roadmap based upon problems that people throw at us. So if you've got a problem in your OT or ICS network and you're like, well, CT could solve it, talk to us. If you've got another that you're like, but could you solve this one? We love to know and understand and look to fix things. So yeah, and as you can see, I'm also very chatty. So if you want to chat, hit me up.
Yeah. No, that's fine. That's fine. Where's your company located? Is it in UK or US?
No, we're a US based company.
US.
Um, so we have headquarters in Charlotte, North Carolina.
North
Um,
Carolina.
but I'm based in the UK. But I'm only a person in the UK. Most of the teams in the US on the East Coast.
Oh, I see. Are you the only British guy in the company or what?
I think I am actually. Yeah, I'm representing.
Nice, nice. Okay, okay, Philip. Thanks for coming
Pleasure.
and take care. Thank you very
Thank you
much.
so much.
Bye bye
Bye
then.
bye.
Bye.